Hello, this is Blastertoad speaking, and I am back with another tutorial. I am hoping to be back more often and more regularly now, and yeah, let's get right back in the swing of things. To celebrate my return, I am going to be redoing, or providing a new method, a little bit more advanced method, of performing one of my most watched tutorials, and that is the Weeping Angel, or SCP-173 type creature, where it is a creature or an enemy that only moves when you are not looking at it. So, with that being said, let's jump right into it. Pressing this little button at the side gives you your content tree, and this is going to be a right from scratch, fresh build, or fresh, no content games, so you can follow around right from beginner to the more advanced stuff. We're going to go all the way through it. So we're going to set up some folders here. So we're going to have Blueprint folder. Under Blueprint, we are going to have Character. And we are going to have Enemy. Under the content folder, we also want levels, and we want widgets. That's all our folders set up. Let's go about creating our basic character. First things first, we're going to set up our inputs. We're going to go edit and project settings, then over to input. Axis mappings, we're going to want a few of these. We're going to want to be able to walk, strafe, pitch, so looking up and down, and yaw, looking side to side. Yaw is going to be mouse X, side to side. Pitch will be mouse Y, up and down. However, I am going to set my mouse Y scale to -1, because otherwise it is inverted. If you prefer inverted controls, you can set that at 1, but I'm going to have non-inverted for my camera views. For strafe, we need to add another one here. On our first one, we're going to have D. The right direction is positive in Unreal. And for left, we want A. And we'll set that to a scale of -1. Walking, forward is positive with W. Reverse, S will be negative. We're also going to add an action map. So whereas these are scaled inputs, an action map is a button press. And we're going to have blink as a button press. Whoever, or any of you that may have watched the advanced Weeping Angel tutorial with blinking and that, we're going to be building that full system, but in a much cleaner way. Okay, so let's get this basic character set up. We're going to go into our character folder. Now that we've got our inputs, we're going to do a new blueprint class of character. I'm going to call this character_player. Hopefully that got named right because I can't see it. Yes, it did. Open that on up. We want a camera for our character, so just going to add component, camera. And then we're going to go over to our event graph. Instead of building anything here, I like to clean things up by using different graphs for different functions. So I'm going to add a new graph for input. That automatically bumps us into that new graph. I'm going to start populating that with our input events. So we want to walk, strafe, pitch, yaw, blink. There we go. Ooh, with the magic leap thing being in there, where they already have an eye blink component, imagine making this for an AR headset, where it was run on your actual blinking. How long can you keep your eyes open in a hot and steamy VR headset? That would be an interesting horror game. We're going to add movement input for our walk and for our strafe. On these, axis value goes in scale value. And for our world direction, for walking, we want to get after forward vector. And for strafing, we want to get after right vector. Blinking, we're just going to move down because we're going to handle it later. Pitch, we are going to add pitch, add controller pitch input right there. And yaw, we are going to add yaw input right like that. So if you take a quick look at your class defaults, under pawn, you've got this here where use controller yaw is on by default. This means whichever way we turn the controller, where we're adding input to it, our actor will turn to it. We could set pitch as well, but if we look at our character, we've got this oval thingy here, rotating around the center. If you go to pitch forward, you roll that all over like a football falling over, American football falling over, clarify. And that's not really the aesthetic we want to go for. Instead, we're just going to drive the camera. So we're going to get the camera that we made. We are going to add, nope, not add. We are going to set world rotation. And we are going to set it to control rotation. Right, like that. Compile, save. Now if we go, we're gonna make our level a little bit bigger. I'm just gonna scale this up to 5 on the X and on the Y. Gonna drop our player in here. And with our player selected, we can go into our details panel, type in possess, and for testing, I'm going to tell it to auto possess player 0. That is auto possess player and select player 0. The first player that joins will jump in that character regardless of any other settings or game modes. Now if we hit play, we should be able to look up and down, left and right, move forward, back, and side to side. We have our basic character. There you go. Now let's move over to our enemy. Our enemy, we are going to do similar stuff. We're going to get a character. We're going to call this character underscore enemy. Going to go blueprint class, drop down all classes here. I'm going to search for AI controller. Get one of those and call that AI underscore enemy. Okay, then I'm going to right click again under artificial intelligence here. We're going to get one of these, each of these. So Blackboard, I'm going to call this BB for Blackboard underscore enemy. And behavior tree, a BT underscore, you guessed it, enemy. And there we are. So we'll do the easy stuff first. We're going to set up our character, our enemy character. So we're going to go in here, compile, save it. We're going to build a bit of a body just so we have something to look at. So just going to scale down a cube to get basic body dimensions. Add a cone. I didn't grab where I wanted to grab. I want to grab right in the center. Come on. Grabby right in the center. There we go. I'm going to move it forward and down just a tad. There we go. And this way we've got a direction and a body for our enemy. Under class defaults and under pawn here, we want to make sure possess AI has a setting here. Place in world would be if we set it in the world manually in the level editor, it has AI. But I also want to be able to place or spawn it in the world. We're not going to be spawning anything. We're only going to be dealing with placed ones. I just like to set this so that when I, in the future, go to say, okay, spawn in enemies on a timer or on an event or something, then they spawn in and they have their AI. I don't go, oh, why is my AI not working? So it's more just a sanity check for myself. Under controller class, we want to set our controller of AI_enemy. And that is it for our enemy character. We're going to compile and save. We want to go over to our AI controller, so our AI_enemy. Get to the event graph. On begin play, we are going to run behavior tree. And we just want to select our behavior tree enemy. That is all we need for our enemy character and for our enemy controller. Those bits are super easy. Now we get into the little bit more complex stuff. Okay, so the behavior tree and the Blackboard. The behavior tree is going to be what tells our character how to behave or what to do. Go figure with a name like behavior tree, eh? The Blackboard holds values or holds variables. So we're going to open up our behavior tree. We see Blackboard button here. We're going to go there and we're going to select BB enemy as our Blackboard class. We're then going to delete the self actor it gives us. We're going to add two new keys. One Boolean. We're going to call can move. And one object we're going to call target. The object needs a little bit more setup here. So just under key type, hit this little arrow to drop down more options. And we're going to select actor. Okay. Save and back to our behavior tree. So our enemy is going to be super simple. It's going to run through a sequence of things to see whether or not it has a target and if it can move. And then if all's good, it's going to move. We're going to do a sequence. And then we are going to move to. Okay. If the Blackboard target is already set up as an actor, you'll see move to target. Or move to already has target selected there. And we would just want to double check that's all right under Blackboard. Observe Blackboard value. And target. There we are. Now, we don't actually do any of our logic here. This is more of just a layout. Okay. Our logic is done in services. So we're going to do a new service. Okay. We're going to close that right away because it makes a service with a stupid name. I'm going to rename that to BT service underscore find target. I'm then going to duplicate that and do a BT service underscore can move. Okay, let's work on finding a target. If you get a screen like this, open full blueprint editor, and hey look, we've got an editor graph. It looks fairly familiar. We're going to use an AI specific node, AI tick. A event receive tick AI. So something to remember always, for pretty much anything other than AI, try to stay away from tick, because tick happens every frame of your game. Okay. However, the AI tick is meant to be run and have logic tied to it, and is set to not run every frame, but in intervals. And we'll see that a little bit later. But just something to keep in mind, pretty much anywhere else, try to stay away from tick, do it a different way. Very light stuff on tick, fine, but that's about it. For the AI, tick is a viable option. Okay. It gives us the controller for the AI, and the pawn, or the body for the AI. We're gonna save that pawn, so we're gonna promote the variable, enemy pawn. Let's straighten that off. And then we're gonna make a few more variables here. So we're going to make a variable, we're gonna call this target character, so target char. And we're going to make this of type character. We're gonna duplicate that. We're gonna call that target memory. Okay. So target char, we're gonna bring out. And we're gonna do an is valid with a question mark. That gives us this nice little executable thing here. Then, off that, if it is not valid, we want to do is valid for target memory. Okay. And if neither of those are valid, we want to find a new target. So we're going to do a custom event, find target. Okay. And we are going to have to validate our target. So before we get through this bit, we are going to make a function first. We're going to do a new function, so plus, I'm going to call this validate target. Okay. We are then going to make a local variable and validate target. And we're going to call that is valid as a Boolean. And then we also want a target character, so I'm just going to cheat here by pulling one in, promoting to, not to a new variable, but promoting to a local variable. And we're going to call this temp character. Okay, we're going to set temp character with an incoming pin. So this is going to be whatever character we're testing against. We could even call this test character, either or. And then we're going to set is valid to false. Okay. And then now we get to do a bunch of fun stuff. So, we're going to get our enemy pawn, and we're going to see if the character we're testing against, that we're trying to validate, is within the field of view of our enemy pawn. To do that, we are going to get after forward vector. We are then also going to get after location. Going to copy that get after location. And we're going to plug our temporary character down here. From our enemy to our character, we want to find look at rotation. And what we're going to be doing here is comparing the way the enemy is looking, so their forward vector, versus which way they would have to look to see the character. Okay, so off of our find look at rotation, we're going to be getting our forward vector. And to compare these, we're going to use dot product. Plug those in there. And then we're going to get a float. We need to convert that to something useful for us. And we're going to do that to angle in degrees. So A cosine degrees. There we go. We've got to that. I'm going to move it along here so that it's not interfering with that, because we're going to be commenting this out. A cosine degrees, and then we want to check whether that is less than or equal. And we're going to make a new variable, so promote to variable. And we want to call this, if I didn't have caps locked on, half vision cone. And we'll put a little eyeball beside that, make it publicly editable. And compile save, so we can set a value on it. We're going to set that to 90 as default value. So that it will give our enemy a field of view of 180 degrees. So if you come up right beside it, it will see you. Okay, and then we're going to do a branch. Come on. Straighten up that branch. Now we're going to select all that, hit C to comment. Now we're going to say is character within enemies cone of vision. And the reason why I'm saying cone of vision there instead of field of view is that this here angle compare is not just on a plane, so not just looking left to right, but is anything within a cone. So it is a cone of vision. Okay, so if that is true, we are then going to do a line trace. We want line trace by channel. And here was one of the major issues with my previous Weeping Angel tutorials, is we did line traces and we used visibility, just like it's set up here. But that means that your character needs to have a body. So if you use something like the first person template that a lot of people were doing, and then following my tutorial, it wouldn't work because your character didn't have a body. What we're going to do instead is use camera, because the character's capsule collision, the big pill-shaped thing at its root, will block camera traces, even though it won't block vision. So this way, your character does not need to have a body, it just has to be of type character. Okay, save. So then we're gonna do a line trace by channel from our enemy. We're going to get actor location. We are going to slightly modify this, so we're going to do a plus vector. Promote that to a variable. And we're going to call this height offset. Clean these up a tad. And compile and save. So what this is doing is this just allows us to add a value to our location. So I'm going to add 60 in the z-axis, so up and down. So that way the trace is coming more from the head or eye area instead of coming from the middle of the actor. Okay. Compile, save. Then our end location will be our temporary character, get actor location, and our end. Now something to keep in mind, because this is all happening on the behavior tree as a service, and not on our enemy or not on our character themselves, we can have some issues with it running into So this is the enemy trying to see out. We could have this running into the inside of the enemy's head as a problem. We want actors to ignore. We want the enemy to be ignored by this trace so we don't accidentally bump into ourselves, so to speak. Okay, I'm going to turn on the debug line just so that we can see that later. On our hit out, we want to break hit results. We're going to expand that, get our hit actor, and check if it's equal. And then we'll use the arrow to collapse that down again. And we want to check if hit actor is equal to temp character. Perfect. And then we'll do a branch. And plug that in. Grab all that, hit C, and then we're going to say here is, or not is, does enemy have line of sight to character? Yeah, pop that all out. Compile, save. So we're checking, or we're setting is valid defaults. We're checking, okay, is the character in the cone of vision? Yes, okay, so it's within the cone of vision, but can I actually see it? Can I draw a line to it? Yes, and if all that is true, we are going to set is valid to true. Now we're gonna click on our function. We're going to add an output. I'm going to say target is valid as our output boolean. We got to go find our output here. Perfect. So we want to get our is valid, plug that right in there. And we're going to plug this in a few places. So we're going to copy it, plug it in there, paste it, plug it in there. And actually this one we can do a double duty on, plug it right there. So this way it's telling us whether or not the character we're testing against would be a valid target. We're just going to compile and save. We can go back to our event graph. So now for find target, we are going to do a for loop off our last index. We're going to promote that to a variable. We're going to call this max players. Just in case you're doing a multiplayer game, it'll loop through multiple characters. And we're gonna give height, offset, and max players, make them public. Then off our index here on our for loop, we're going to get character. So get player character. Right there. So it's getting the player character for that controller index. Nice and nice. So we're gonna then is valid with the question mark. We're going to see, okay, does this character even exist? If it does, then we want to validate the target. And then branch. Okay, and then if our target is valid, we're gonna see whether it's closer to our, actually no, we don't wanna do that yet. We're gonna move that down some. First, we're gonna do an is valid on target character. Okay. So, if target character is not valid, we're going to validate this character, and if it's true, we're going to set target character to this character. Okay. Now we're just going to do a rewrote node here, bring it out, straighten that up, plug that in there as well. Just cleaning up our node a little bit. However, if target character is valid, we want to see whether the target or the new character is closer to our enemy. We want to get our target character, or get player character here. We want to get actor location. Now we're gonna straighten to get actor location. Then we want to get enemy pawn, and again get actor location. Move that down, and it's just running off the out valid. And then we want to copy this, paste, and plug in our target character. So this is going to compare this new character to our target character, which one's closer. So then we're going to do a distance 2. Distance vector, there we go. Control C, Control V. We didn't need that, did we? Because we can do a distance. Yeah, get distance 2 is what I was looking for. Sorry. We're gonna get rid of these. I'm gonna straighten that. So get distance to the enemy, and then get distance to target character. And then if the new character is greater than or equal to the distance to the target character, then we want to continue using the target character. So we're going to do select. So if distance 2 is the same or is greater than target character, we're going to use target character. However, if it is the other way around, I'm going to add a rewrote node here, plug that into false. And then just straighten those off, make it look all nice and pretty. There we go. Okay. Then we are going to, again, validate our target with our function, and then branch. If our target is true, we want to set as a new target. And there we go. So this here, we're going to comment, find closest target. And then otherwise, if target character is not valid, we will set target to first valid character. There we go. Okay, so those are setting our targets. And then here, we will comment loop through player characters. Perfect. This bit I'm doing by the seat of my pants because I've done it about 3 different ways now as I've had to re-record this video. So we'll see if this way works out to be the best way or not. Yeah, so if target character and target memory is not valid, then we want to find target. However, if target character is valid, we want to validate the character. So make sure they are still usable. And then branch. And if they come out as valid, we want to do nothing. However, if they are not valid, we want to set target to nothing. Just like that. Or sorry, if it is valid, we want to set target memory to target character. We want to add it to memory if it passes all the validity checks after it was found. Okay. And then we need a new custom event. So we're going to do another custom event. And we're going to call this one target memory timer. Okay, we got target memory timer here. We're going to do a re-triggerable delay. And we're going to promote that to a variable. And we're going to call this memory time. I'm going to make that visible. By default, I'm going to set that to 2 seconds. If you can outrun and stay away from it for 2 seconds outside a line of sight, it'll forget about you. And then when that's done, we want to set target memory to invalid. The timer to forget target. Okay. So we're setting the target memory, and then we want to run target memory timer. Target memory timer. Okay. File, save. So target memory goes in there. That comes out there. So now we want to do a set Blackboard value as object. This is how we communicate out to our Blackboard and our behavior tree. And we're gonna plug in that, and we're gonna plug in our valid target memory. Our value will be target memory, because it's either set here as our target, or we're going off memory for it. And as for key, we're going to right click, promote to variable, and call this target key, and make it public as well. Okay. Now, the only thing that I can see wrong with this is that when all this is done, so when we go through the find target, we aren't actually setting our target. So we'll want to, nope, that might make an infinite loop. So yeah, we'll just wait for the next tick. So it'll find a target, and then on the next tick, it will set the target. So it adds a little delay to selecting new targets, but not bad. So that is that. Again, let's just do a quick run through. We are saving our enemy character, or our enemy pawn, because we have to reference it a few times. If the target character is a valid actor, we want to make sure it's within field of view and has line of sight. If it does not, we're going to invalidate it. However, if it does, we want to add it to memory. Reset the memory timer, and go out to the Blackboard. If it's not valid, so it's been invalidated here, then we're going to see, okay, do I have a target that's in memory? If yes, go out to the Blackboard value. If no, find a new target. That will loop through all the characters, and then either compare it for distance and validity against the previous targets, or compare it for validity and set a new target. This little here timer is just running a delay until it forgets its target. So yeah, how many times can you say target? Woo! So now that we have find target set up, we can go to our character enemy. Oh, sorry, not character enemy. Our BT, or behavior tree. And on our sequence, we're going to right click, add a service, and our services show up right here. So we want find target. And then we need to do a little bit of setup here. So, find the target, half cone vision, yep, sure, max players, I'm going to set that to 4, memory time 2 seconds, and the target key we want as target. Okay, and then this is going to happen every 0.5 seconds with a deviation of 0.1 second. If we save, and then on our move to, we're going to right click, add a decorator, Blackboard, and just as it says there in its description, this is a Blackboard base condition. And our condition, we want to on results change, invalidate itself so it can break its own setup, and then if the key is set, and the key we're looking at is target. So if target is valid, move to target. If we drop our character enemy out in the world here, and we're going to need something else, we are going to need a Navmesh. That's what we need. I didn't forget it this time. Navmesh bounds. I'm going to set it to center. Set my scale to 25, X and Y. Now I hit play. It's not doing anything, not doing anything, not doing anything. Now it's looking at me, and now it's moving at me. There we go. Oh, I left the camera at belly height on the character. Okay, so we're gonna go back to our character. Set the camera to more of a head height. That's better. And then play, I'm gonna select new editor window. So, the enemy has not yet seen us, has not yet seen us, has not yet seen us, and it has now seen us and starts coming after us. So there's that second of delay. When it sees you once, it has to see you again to start coming after you, which I kind of like. So you can kind of like sneak around a corner and be like, oh crap, and it's back up. If you didn't want that to happen, then in the find target, you could, once this is complete, go up to that, or copy that out. But I like it how it is, where you've got that second of, okay, if it sees you once, you're okay, but as soon as you kind of stand in its line of sight. I think I really like that, yeah. Okay. So now, before we tell the character to check whether or not it can move, or the enemy, whether or not it can move, we need to set up some stuff on our character. We're gonna go back to character, but instead of setting it on the character itself, we're gonna use something new that I haven't touched with a tutorial before, but I've been working with myself, is a actor component. So this is a component that is an actor component is a reusable component that can be added to any actor. This means we can drop it into any actor. Ours is going to kind of need the character class, but otherwise this is a modular piece that you can just drop in and out. So I have come to really like these. Stupid autosave before I can rename this. I've come to really like these to set up things like a hunger or thirst system, so I can just drop that on any character. Right? I don't have to rebuild it each time. It's very nice that way. So I'm going to call this blink component. And there we go. We're going to open up blink component. And we're going to set a bunch of variables here. We're going to have eye hydration max. Make that a float. Gonna duplicate that and then have just eye hydration. So this is going to be the dryness level of our eyes. We're going to have hydration drain and hydration delay. Then we need some booleans. We're going to have dark set as a boolean, flashlight, blinking, can see. Okay. We're going to delete our tick event. We'll use it later, but I just want it out of the way for now. On our begin play, we are going to do a timer by event. I'm going to have this timer run every second, looping, and then to a new custom event, and we're going to call this hydration loop. So something that bugs me in most like survival type games where you've got a meter that's going down, whether that's food or water or bladder or whatever else it might happen to be, is that as soon as you fill that meter, it starts going down immediately. We are going to have a delay. So if your current eye hydration equals the max eye hydration, we're going to branch off. And then do once. And then we're going to run a delay. Which is hydration delay. And then this is going to go back into the reducing eye hydration and just a lower bit right here. But what this is doing is if you have maxed out your bar, it is, instead of ticking down right away, going to give a delay before it starts ticking down. So then we need a sequence. Plug that in there, move these back a tad. We're then going to get eye hydration minus a float, which will be our hydration drain, and set eye hydration with our new value. And we're gonna move that like down here, straighten that off, make these all pretty. Maybe like that. Plug that in there. And then we're gonna do, if this is less than or equal to 0, branch. And this is where we'll force our character to blink. So we need a new custom event. Custom event. Blink. And we're just gonna run that right there. Blink. Blink. And we'll grab all this and comment it with eye hydration level drain loop. Okay, so then if we blink, we're going to set blinking to true, but we're going to do that after a do once so we don't accidentally trigger this happening a couple times in a row. We don't need that. And then we want another event. We're going to do a custom event and blink. And then on end blink, we're going to set blinking to false. We're going to reset our eye hydration, so we're going to just set eye hydration to eye hydration max. And then we're going to reset the do once node there. To make this visible to the player, we're going to go about making a little animation now. So we're going to go over to widgets folder, right click, user interface, and widget blueprint. I'm going to call this UMG for Unreal Motion Graphics underscore blink. Open that up. I'll want a border. Our anchors are going to be across the top with 0 offset to either side, 0 position, and 550 height. Then going to call this border top and make it black. Okay. I'm gonna duplicate that. Put the anchors at the bottom. Make its position negative 550. And we're gonna call that one border bottom. Got border top and border bottom. Okay. We're gonna move this up, scroll it out a bit so we can watch what's happening, and we're gonna add a new animation and call that animation blink. And then if you select things here, then when you add a track, it'll already be here. So border bottom and border top. Switch those about. Gonna compile and save. Then we want to add a transform track to each. Transform. Gonna expand those. And translation we're gonna expand. So I want them to start partially open. So let's try something like negative 350 on that. Yep, that leaves a bit in the top open, and then 350. Okay. Then in like a 15th of a second, you want to set those to 0. And another 15th of a second, and a 20th of a second. We're gonna hold for a 20th of a second, I should say. We're just gonna hit those plus to add another key. And then in a 10th of a second, we're gonna go back to that partially open state. And if we play this, we should get a real quick blink. Okay. To make this look a little bit better, we're gonna do some fading here and add a render opacity track to each. At its beginning, we want its render to opacity to be 0. Just before it's fully closed, we want that render opacity to be 1. Then just about as there's to start open, we want that render opacity to be 1. We're just gonna add our pluses. And then when they're open, we want our render opacity to be 0. So that should now give us a nicer blink. And to really sell the effect, we are going to add a blur component, background blur. Nope, I don't want it as part of anything. Our anchors will be the full screen. We want 0 offset, so it covers everything. And the blur strength, something to like 5, maybe. Compile and save. Okay. Last thing we need to do on our animation is have it trigger something. So we're going to add a new track, an event track, trigger. Right at the end, we are going to put a plus, add a new key, right click that, properties, it is currently unbound, we want to create a new endpoint. It's going to make this sequence event 0 is what we're going to use. Let's go to our graph. First things first, when the widget, when the UI here is added to the screen, which is event construct. It's kind of like begin play for the widgets. We're going to get blink, which is our animation here, and we are going to play animation, just like that. Okay, then we're going to go over to that sequence event 0 that was made for us. On sequence event 0, we need a new variable. I'm going to call this blink component. And we want to set that to type blink component. We'll pull that out here. On blink component, we want to end blink. And then we want to remove this widget. So we will remove from parent. Compile and save. We're going to go back to our blink component now. So on blink, we're going to set blinking to true. We are then going to create a widget. That widget is going to be of type UMG blink. We're going to set blink component to self. And then we are going to add to player screen. Okay. Gonna grab all that, comment, blinking. Perfect. compile and save. Then we need to set whether or not this character can see. So we're going to do a tick event tick. We are going to get dark and flashlight not. Sorry, just straighten things up a bit. Or blinking. And then we want to set not. We want to not there and then set can see. So if it's dark and we do not have a flashlight, or if we're blinking, set can see to cannot see is what this here says. So in this tutorial, we're not going to be playing with dark or flashlight. However, it's something you'll be able to very easily expand on, whether you want to set dark from your game mode and get all components of class blink component and update it, and on your character turning on or off flashlight. Those are very easy things for you to do, which I'm going to just leave hooked in here, but we aren't actually going to touch it, so that when these project files are available, and they will be available to any Patreon members, which I am just setting up now. So, spoiler, Patreon members of the new Patreon setup will get access to project files. Okay. Yeah, then you can hook things in here really easy. And is a nice little challenge for you to expand our logic here. We've got blinking, we've got can see. Beautiful. Now we're going to go to our character. We're going to add component. We want to add a blink component. Then we're going to go down to our input for blinking. Gonna get our component. And then blink. So this way we can manually blink. And this would be the same way as like if you had a flashlight button. Set flashlight on or off. That's that. So nice and easy to hook into, and you can drop it on a third-person template character. You can drop it on a first-person template character. You can drop it on any character class, or pretty much any, any character class, because it is looking for a class of character in the AI. But yeah. So it makes it really nice and easy to drop onto other stuff if you're wanting to build this into your game. We're gonna go back to our enemy, and now we're gonna set whether or not our enemy can move. So let's go, and we're gonna get, we want AI tick, AI event receive tick. We're going to get our controlled pawn, promote to variable, enemy pawn. This recording better come out good, because again, this is like the third time I'm recording it. Having to reset all your video stuff after getting a new computer and having like multiple updates of things changing because I haven't made a video in it feels like almost a year. Yeah, it's rough and rusty and all the rest of that. Yeah. Okay, we're gonna do a for loop. Last index, we want to promote to variable, max players. We're going to make max players visible. For each index, we are going to get character is valid. So just making sure the character actually exists at that before we go about and try to do things with it. Then we're going to get component by class, and we're going to get our blink component. I'm going to check is valid. Okay. So if there's a valid blink component and the player is valid, we need to see, is the enemy in its line of sight, or can the player see? So let's get can see. Okay, and then we want to get forward vector, not from the mesh, get actor, forward vector, and then get actor location, copy get actor location, plug in enemy pawn, find look at rotation. This should all seem fairly familiar. Dot product, do forward vector. Converting that to degrees. Less than or equal. And in this case, this is for our player's thingy, camera view. So by default, the characters have a 90-degree field of view on the camera. Okay, so if we set this to 45, it would be our half view, just like we did for the enemy. However, if something was just at the edge of the screen, then it could still move before it was triggered. So we may not want that. So we may want just beyond the field of view. So instead of setting it at 45, I'm going to set it at 50. And then we're going to do an and Boolean up here. So if the player can see and the enemy is in their field of view, we are going to run more logic. Okay, but otherwise we're going to stop right there. The other thing we want to do is move all of this down. So I want to set a variable before doing any of this. A new Boolean, perfect. Can move. We're gonna set can move to true. Okay. Then we're gonna do all of our checks, and if the player can see the enemy, we're gonna set can move false. We're going to assume true until we do all our tests. Okay. Actually, we're gonna move that down so that we can comment it by itself. C for a comment, and we're gonna say for each character, check if they can see and if enemy is in field of view. Okay. Compile, save. Okay. So, next, we're going to do something a little bit all over the place as far as the nodes go. So we are going to, actually, we want to save this character. So promote to variable, temp character. I'm just going to plug that in line right there. Okay, because we're going to be referencing it over here. So we're going to get our temp character. Okay. And on temp character, we're going to get after location. Okay. Plus a vector. And on that vector, we are going to get capsule half height. Ooh, without the hemisphere on the top. Yeah, sure, let's get capsule half height without hemisphere. That is a long ass node. We're also going to get after right vector. We're gonna multiply that vector by float, and that float is gonna be off our capsule component. Get radius. Are we doing unscaled? We're doing no, we want scaled. We'll do scaled. So scaled half height without, get scaled half height without hemisphere. There we go. So what we're doing here is, whereas on the enemy, well, actually, let's just go back a second. So on find target, when we run this validate target, we are doing from the enemy's line of sight, or from the enemy's eyes position to the character center is what's happening right there. But for the character, we want to see basically if the player can see any part of the enemy. So to take care of that, we're going to go through 4 corners of the enemy, or 4 corners of the player, instead of tracing from a single point. We're getting the right vector and adding the capsule radius, so we're going to be off to one side, and we're getting its height, so we're going to be up or down, because we're going to multiply those to get different things. So we want to make vector, and we want a Z out of that. And we want that. And then we want to multiply float. Now this is where it's going to get fun. So because we need to do 2 of these with one of these and one of these flipped, and 2 of these with one of these and one of these flipped. So we need to do 4 different things that we're going to add to here, and we just want to figure out how to do that programmatically. So we're going to definitely add those together. So add to that. Or, let's do a make array. Make array. Okay, so we're gonna put that in there. Straighten, we're gonna straighten. We're going to put all of these into a single point there. Move these back. And we are going to do a reroute node and a reroute node. Then we're going to get all of this. And we're going to collapse to macro because we're going to use it a couple times. And we want to, on our input pins, we're going to move this up. Our input pin is our character. Okay. B2, we're going to move up. And that is going to be our X, or our Y. And this will be our Z. Okay. And now to just try to make it look pretty, we're gonna plug in there, get rid of that reroute, straighten connection to our get right vector target, bring those up, you can fold this under like that to make it look reasonable. We'll line up these two multiply nodes, give them a couple redirects. See, what once looked like a spaghetti is now mostly readable. Okay. Corner offset from character. Compile and save. Okay. So we need a few of these. So we're going to need a 1 and a 1. So this is on the head to the right. We need a -1 and a 1. This is on the head to the left. We need a 1, -1. Which will be a on the right on the toes, and a -1, -1 on the left on the toes. Okay. I'm gonna plug our temp character into each of those. And then we're going to do a for loop. Last index will be 3, because we're just matching our array here. We're going 0 through 3. I'm going to plug in our for loop. Straighten. Bring it back here. See, it doesn't look so bad once we get all this compressed, but a moment ago, it was just spaghetti. Like, it's still not great, but a moment ago it was unreadable, so. And we are going to, off this array, get, plug our index in there, and plug that in there. So that is our 4 corners of our character. Now, we do the exact same thing, except for instead of character, we put in enemy pod. Oh. Cast to character, convert that to a pure cast, because our enemy is a character. Let me just plug that in. So from the 4 corners of our player to the 4 corners of our enemy. And then we'll put our index in here. We're going to do a line trace by channel. Again, we're going to trace on camera, starting from our character, going to our enemy. I'm gonna break hit results, hit actor equals, collapse those hit results, straighten it all up. If our hit results equal our enemy, we're going to branch and here we want to hit set can move to false. Okay, so we're gonna select all this and comment is enemy in line of sight to character. We'll do a debug, and we're going to set this as a different color, so the enemy's debugging red, we will debug blue for our character. And when all of this is done, so on our complete here, we'll want to do a Blackboard value as Boolean. We're going to set our key from can move. Sorry, set our value from can move, and for key, we're going to promote to value, or promote to variable, and we're going to have can move key. And we want to make that publicly editable. Compile and save. And there is that insanity. We're going to go back to our behavior tree. On our sequence, we're going to right click, add a service, and we're going to add our can move. Going to select that. Can move key is affecting can move. That's exactly how we want it. And max players, we want to set the same as the other to 4. But the thing we do want to change here is we want the can move to happen more often. So we want to set that to like 0.1. We're going to save. Target is set, so yeah, we want to add a decorator from Blackboard. We want can move is set and abort self. So again, so this is now checking, do I have a target and can I move before it tries to move to. Okay. I feel like there is something I'm forgetting. Oh, our blink component. We left everything as zeros. Our default values. We need to change that. So eye hydration, I'm gonna set as 100. Okay. It's on a 1-second timer. So I'm going to set the drain to 10. So in 10 seconds, it'll drain down. Hydration delay. 2 seconds of delay before it starts draining again. Sure. Now if we hit play. Ooh. Uh-oh. I did a stupid. Okay, so we want to go back to can move. And within all this mess here, we need our temporary character to be ignored by the line trace. So nothing bumps up against a temporary character. File and save. Now, if we hit play and I make our window a little bit bigger, we have blue lines from our four corners to the four corners of our enemy. And then we have a red line hitting us, and when we blink, it can move, but otherwise, it can't move. Okay, let's set up a level with this now. Okay, so we're going to, from our, I'm just going to move that down so I can get a bigger editor here. Go to geometry here at the side. I'm going to select a box. Gonna scale this about a bit. Ooh, not that quite that thin. There we go. Say this thing's in a room or something. I am more, well, I was more a Doctor Who fan until the most recent series, so I always base this on Weeping Angel, but SCP-173, we're gonna say this is, we're going into the compound where the SCP thing is. It's in a little room that nobody's supposed to enter, but somebody left the door open because they're an idiot. And they're like, oh, whatever. As long as somebody can see it, it can't move, right? And it's like the one person that's supposed to be sitting there took a nap or like died of a heart attack because they're old. I don't know. But for whatever reason, in our little subplot here as we build our level, the SCP creature is in an area with an open door with just a hallway out next to it. So we can't see anything, nothing can see us, we can't see anything, nothing's coming after us, nothing's coming after us, nothing's coming after us, nobody cares, nothing cares, we blink, still nothing cares. But as soon as we come around here, there it is. It just saw us. And if we blink again, it's come around the corner. And then if we go around here, oh, there she is. And there it is again. So the other thing you could do is like just make this thing stupid fast because it's a character. It has the character movement component right here, where you can change all of its values, like what its speed is and all that. So if we set walk speed from 600 to 6,000, compile and save. So now it's like no matter, oh, it started playing and I wanted to resize the window first. But now it's like, no matter where we go, once it sees us, it should be like right around the corner. Yeah, like right there, just like boom. Was the shit. Boom. Or you can set that even higher for like instant. Oh, okay. that one kind of got me. Blinkety, blinkety. Okay, so let's set up as the final piece of our puzzle here, because I'm actually running ahead of schedule on this recording. The last one was like an hour 50. This one's only an hour 30. Let's add a HUD for our eye dryness. So we're gonna do widgets, user interface, widget, UMG, underscore, HUD. We'll just call it HUD. And on our HUD, we aren't going to do any animations, or at least I'm not. I'm just going to do some very simple text. Eye hydration. Size to content, sure. And I'm going to get a border. Border is going to be like that, and it will be red. And I want that border inside of a panel. What type of panel doesn't really matter. We'll do a horizontal panel. No, not a horizontal. I want an overlay. Yeah. An overlay panel. And the border will be inside that overlay panel, which is now up top because stupid things. That's not what I want either. If anything, I want the anchor to be at the corner. Okay. So I'm just going to tell that to... Can I have it fill the space? Yes, I can have it fill the space. Perfect. We're going to our overlay box. I'm going to make that like that, maybe a little thinner. And then we're going to duplicate our border. And the one that is on top, which I think is lowest in the order, we are going to change its color. Yeah, nice like happy green. We're going to make this a variable. Border underscore hydration. And then we are going to want to clipping. Clip to bounds. And then let's test something. If I translate on the x-axis, yes, but it should be clipping to bounds. So, clip to bounds always? No? Overlay. Clipping. Clip to bounds. I need to do it on that. So on border hydration, we'll just inherit. Perfect. So I want that to be 0 for now. Or no, I want... Yes, I want that as 0. Okay. I'll save. We are then going to do a bind of visibility. Sure. Create binding. We're going to leave the visibility alone. But what we want to do here is we'll get a new variable for blink component of type blink component. I'm going to pull that out here. We're going to get eye hydration and get eye hydration max. We're going to divide the little one by the big one to get a percentage. We're going to multiply that by a float. Our float is going to be... What's our X size on this? We'll call it 250. So we want to multiply that by 250, but negative. And then we want to get our border hydration. Transform. Set render translation right there. Split, and on the X, I want to set that. This should make a progress bar of sorts. Whenever the value changed, it will set the visibility to true and scale our bar. Now we just need to go to our blink component. I still have it open. And on begin play, create widget, UMG HUD, set blink component, self, add to player screen. And the only reason I'm using player screen is just in case you were to say make this into a split screen game, which everything should work with. I haven't tested it, but it should work. In case you wanted to, it would put it on that player's screen instead of over the whole screen. So now, it's going the exact opposite of what I want it to. So I need to times by, if I make this positive, will it do what I'm wanting it to? We'll soon find out. No. It just fills from the other way. So if I get... So I want it to go to negative 250. When eye hydration is... Oh. Flip that? No. I do want the 0 to 1 that this is going to give me. But I want it 0 to 1 in the opposite direction. So I want to do a lerp. Float lerp. My alpha will be this. Okay. So, if we are at 1, we want to be 0. But if we're not at 1, we want to be negative 250. Save, and there we go. Look at that, eye hydration starts going down. And blink. And it stays up for a bit, and then it starts going down. And if we come around here, oh, and then we blink, and did he remember us? Yeah, he did. Oh. Yeah. Now imagine having a couple of these in a game with a few players playing. Be pretty awesome. So again, the reason for the 4 corners is on corners like this, because if we're tracing to its center, it would come around that corner completely. Whereas on this here, we should be tracing to, oh crap, no, because we're cross tracing, aren't we? So if we look at it head on, we are crossing, which we don't want. So we need to go to our enemy can move, and we need to set our Y values to opposite. So from positive to negative, from negative to positive, positive to negative, negative to positive. So this way, when we're looking at each other, which should most often be the case, so when we're looking in the same direction, we're crossing. But now if I go look straight face to face with the thing, we are no longer crossing. So if I go around a corner, yeah, see, he sneaks around the corner less now. Except for then, because he's stupid fast. But if we don't have him as fast, so if we go to our character enemy, we set that walk speed back down to 600. Let's give that a run. And he sees us. And doesn't sneak around the corner so much. Oh, see, he's right there. It's like just barely being rendered in. Boom. Yeah. You'd have to play with speeds, and you may or may not want to play with the crazy offsets in the can move to do the 4 corners. Just tweak that up a bit. But yeah, that is the 2020 Weeping Angels using Unreal Engine AI and actor components. So, I hope you've enjoyed. Please let me know in the comments what you want to see next, or if you have any problems. Of course, if you do have problems, it is best if you can jump on our Discord, and we have a section, a specific channel for Unreal Engine queries, where you can drop something in chat there, post some screenshots of your blueprints, and a few of us can look over it together. So yeah, we'll see you around the Discord channel. We'll see you in the comments. Thank you again for watching, and especially with this video, because I'm still tweaking audio and screen scaling and all that. Please let me know how the font sizes were on the screen for the blueprints and that, because I'm running it on a very large monitor in front of me, so I have to have it scaled way up so it actually looks readable for you guys. So please let me know if the scaling is okay, or whether it needs to be bigger or smaller. Let me know about the music volume behind my voice and all that fun stuff. And yeah, we'll see you next time. Bye for now.